So let's say JRandom Troll and I join a circus. I decide teaching is no longer my thing, and because you all know I have impeccable balance skills, I do this act with JRandom Troll where we're essentially on a seesaw, standing on opposite sides. So, step one, I'll draw a free body diagram of the picture. Let's talk about the torque on this beam that we're standing on. My weight is being acted downward at my location, F weight Martin, and JRandom Troll's weight is being acted downward where he is. So F weight JRandom, both pointing down at opposite ends of the seesaw. There's going to be some upward force, some normal force from the fulcrum, and the beam itself will probably have a little bit of weight. So that's step one. Draw that free body diagram, identify all those forces. Step two was just select a possible axis of rotation. Usually it's helpful to pick a point where there's some unknown force. Well, I don't know the normal force or the weight of this beam, so I'm going to slap the axis of rotation right there. Step three. Make a note of how far each force is away from your axis of rotation. So there's nothing that says I have to be the same distance away from JRandom Troll, so I'll say RM for RMe, and RJ for RJRandom Troll. Make a note of those distances. Next up, you're going to decide which forces are attempting to rotate the object counterclockwise or which are trying to rotate it clockwise. So looking at this picture, I've got the axis of rotation right in the center of the beam. I'm on the far right side of it. So if no other forces existed on this thing, I would cause the beam to rotate down clockwise. So I would treat my torque as a negative one. Meanwhile, JRandom Troll, since he's on the left side of the beam with the axis in the center, if I went away, he would cause it to rotate up clockwise. So that means JRandom torques is positive. JRandom's torque is positive. Next up, set the sum of all the torques equal to 0, assuming it's an equilibrium problem. If it's not an equilibrium problem, if the spinning is increasing or decreasing, I would set it equal to I alpha. But if it's not spinning, or it's spinning at a constant rate, I would set the sum of all the torques equal to 0. So the sum of all the torques would just be JRandom's force times his radius times the sine of theta, which is going to be 90 degrees, because here's the r-axis, here's his force, that's just 90 degrees. Same deal for mine. Mine would just be 90 degrees, and the sine of 90 is just 1. So I would take all these torques, his and mine, and set them equal to 0, where mine gets a negative out front. So his weight times his radius has to equal my weight times my radius in this one example. Not only that, I could then set the sum of all the forces equal to 0. If you call up or down to be positive or negative, then I could solve for any other unknown forces. So once I've figured out what my weight is, or what JRandom's weight is, or whatever it is that I'm trying to solve for, from here, all I gotta do is look at, well, that's a downward force, that's a downward force. I would treat those as negative versus the upward normal force. Solve for that